Okay, so lesson 2 on transformations. On Tuesday, we talked about transformations in general. I give you a function, the basic function, general function, y is equal to f of x. And then we do something to that function and we translate it from there. It is transformations lesson, transformations lesson 1. Now, what happens when I give you an actual function? Here's a function. What did I do to this function, Karen? What moves did I apply to this function? Okay, so that's the more common mistake that we make here, right? It's 4 to the right. Okay. Think about a couple ways. What I can do here is it's 4 to the right because I need a larger number to get the same output number. I'm subtracting 4 from that x to begin with, so I need to be over here before I get the same output number of 0. The other way of thinking about it is x subtract a positive 4. Positive 4 moves it this way. That's a shortcut method, not more the understanding, but it's a shortcut method for this. So we move it 3 up and 4 right. Now we want to plot this. So actually, I'm just going to get some points off my graph. We have the points 0, 0, 2, 2, negative 2, 2, 4, 4, and negative 4, 4. Those are points that I pulled off the graph or pulled off the function, the original function. Again, I like this idea of doing this. We are going to go 4 right. So that means the point 0, 0 became the point 4, 0. This became 6, 2. This became 2, 2. This became 8, 4. And this became 0, 4. So by moving it 4 right, I changed all the x coordinates. And then I am going to do the 3 up. Now I probably will do this most often in one step. I'll do it with my translations. It's easy to do it in one step. So now I've got the point 4, 3, 6, 5, 2, 5, 8, 11. Nope, not 8, 11. 8, 7. 8, 7, and 0, 7. Which now allows me to plot my function relatively well. 4, 3 is here. And once you plot the points, I'm just sketching. Feel free to plot those points. There's my new transform function. Okay, so this is the original function. This is the transform function. Okay. Notice our mapping notation here. This is not what comes off of here, where it's coming off of the 3 up and 4 right. Every point x, y became x plus 4. Every x coordinate was 4 times bigger. Every y coordinate, or not 4 times bigger, 4 bigger. And every y coordinate was 3 bigger. So this here, the mapping notation, corresponds to what we did to the coordinate points for that system. Now let's look at this function. Y plus 2 is equal to x plus 5 squared. Now, you can work with it in this, or you can define this explicitly, i.e. get the y value, the y by itself. And it might be easier to see what happens to the graph in terms of the up or down. Brooke, what did I do to the graph y is equal to x squared to get to this point? What moves did I apply? 5 left, 2 down. Okay, so again, I haven't given you y is equal to x squared, but certain points on y is equal to x squared. I'm just going to quickly create a table of value. -4, well, let's do this a little bit. -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. The table of values. We went 5 left, 2 down. So 5 left of -2 is -7. 2 down is 2. 5 left of -1 is -6. And we are 2 down, so that's -1. This is -5, -2. This is -4, -1. This is -3, +2. So again, I performed everything with all of those. So I just added and subtracted as required. Because it's only transformations, I did it in one step. If I have stretches and reflections and then transformations, I do it in at least three steps. So plotting your graph, we have -5, -2, -4, -1, -6, -1. We have a parabola. That's a terrible parabola. A little bit better. Okay, no, it's a sketch. Not a graph, it's a sketch. Again, my mapping notation comes from here. X, Y became x minus 5. Every x coordinate was 5 less than it was to begin with. Every y coordinate was 2 less than it was to begin with. Again, that does not correspond directly up to here. We determined what this function notation told us to do to the graph, and then the mapping notation tells us what to do to the coordinates of that graph. Okay, so we have a dotted line. I want to know what the equation that gives me that dotted line does. Now, because I'm only asking you for translations right now, we only have to figure out what did I do to it left, right, in terms of moving, what did I do it to up, down, in terms of moving. So in this case, the easiest point for me on this guy is it looks like I moved it 4 to the left and 5 down. Is that, you guys probably have the grid a little bit better showing there, right? So we went 4 left, 5 down. Okay. What did I do? Did I miss it? I miss it? Guess I'm gonna have a short lesson today. What did I do? How do I change my function here? How do I get my function to move? So what do I replace the x with? What do I replace the x with to move it 4 to the left? X minus 4 or x plus 4? Aurora? Plus 4. So I've replaced the x in x squared and with x plus 4. What do I do to that function after I square it? Add 5 or subtract 5? If I'm doing it out here, it's subtract 5. Because I take the function, I square it, I get an output number, and then I subtract 5 from that output number. The other way that you can think about this is x plus 5 is equal to x plus 4 squared. You can think about replacing the y with y plus 5 to move it down. We don't have to have as much output, we don't have to have the larger output numbers to get the same thing. And so these are both the equations of your graph. Now, with this graph, the only difference is I don't actually have a graph for it. I don't have an equation to describe it. This is called a piecemeal function. Piecewise function, not piecemeal function. It's described by 4 different lines, which I'm not going to bother doing. What did I do to this graph? You go from the solid line to the dotted line. Well, the easiest way is to pick a point. Doesn't matter, pick that point. It went from -1 to 3. And this guy is 5. So this was -1 and, oh my, 2. Is it 4 or 5 on yours? 4, thank you. So I went from -1, 4 to 3, 5. 3, -5. So I moved it 4 right and 9 down. My equation becomes, so if I want to think about it this way, if I take it and I replace y with what? Do I replace it with y minus 9 or y plus 9? Yep. So y plus 9 is equal to, in this case, f, because our function is described by a graph, not an equation. And I moved it 4 to the right, so this is x minus 4. Or I'm perfectly happy with either of those. So this is defined explicitly. This is an implicit difference, or defined implicitly. Explicitly means there's a variable outside by itself. Again, I want to talk about mapping notation for this. Okay. It's different than the equation. The mapping notation for this guy here, xy became, every x coordinate got 4 smaller. I subtracted 4 from every initial x coordinate. I subtracted 5 from every initial y coordinate. These are not the same. They're backwards in this case, right? Because this is what we have to do to the function, or when the function, the rules being applied, what do we have? This one is just applying it to the coordinate points of. Over here, the 4 right and 9 down, the coordinate x, y becomes, so every point became every every X coordinate became 4 bigger. Had to move it this way, so we had to add 4 to it. And every Y coordinate lost 9 points. Is that all I had on day 2? Okay. Are there any questions today? If there are no questions, that's your homework. So this is textbook. This is textbook. This is whiteboard work, and then this is in your textbook again also.